Alright, in this lesson we're going to be solving a system of three equations and three variables. By the way, it's storming outside, so you may get to hear a little bit of that. Let's get started. Here's a system of three equations and three variables. And the first thing I want to talk about is the steps we're going to use to solve this. So the first step, or our goal at the beginning, is to obtain two equations and the same two variables. We know how to solve a system of two equations and two variables, so if we can get that, then that's a great start. Step 2 is to actually solve the system that we get at step 1. So we're going to know two of the variables, and so finally we'll use one of the original equations to find the third variable. So let's go ahead and do this. So here's our system. Let's label our equations. Now the thing we want to look at here is x, y, and z. We got to figure out which variable would be the easiest to eliminate when we add any of the equations together. So if you look at equations 1 and 3, we could actually add those together and we would eliminate y because we have a minus 2y and a plus 2y. So let's go ahead and eliminate y. So basically we're choosing to eliminate y. So first of all, I'm going to work with equations 1 and 3. And these are the nice ones because all I have to do is add the equations together. And I'm going to eliminate y. Those are opposites. So the new equation we'll call equation 4. And then let's go ahead and use equation 1 with equation 2. The only thing is if we want to eliminate y, we really need this y to be a 2y so that we're going to have opposites for y. So we're going to have to multiply equation 2 by 2. So let's go ahead and do that. So this is just equation 2 multiplied by 2. So notice we do have opposites in our y's. And so when we add the equations together, we get a new equation. We'll call that equation 5. Now, one of the things I want to point out here is in the to get equation 4, I added 1 and 3 together. Since I hadn't used 2, I had to use equation 2 when I did the second, to get that second equation, and I chose to use 2 with 1. And so now we have two equations and the same two variables. Since we eliminated y each time, we have two equations in x and z. So again, we know how to solve a system of two equations in two variables. So I'm looking at this and I'm looking at the z here, and I'm thinking it'd be really nice to have a minus 5z there. So if we multiply equation 4 by negative 5, then that's going to make this work. So there's equation 4 multiplied by negative 5, and there's equation 5. So now notice we are going to have opposites here, and so we do eliminate z, and we're going to get x equals 2 here. Once we know that x is 2, we can go back and use either of equations 4 or 5 to find z. So I'm going to go ahead and use 4. So that's equation 4. We know that x is 2. So let's see, we need to add 4 to both sides. We're going to end up with z equals 1. So far we know that x is 2 and z is 1. So we still need to find y. So now we can go back to one of the original equations. Let's go ahead and use equation 1. So this is equation 1. We know that x is 2 and z is 1. So I've plugged those in. And so now, if we add the 2 and the 3 there, that's where I'm getting 5. We'll subtract 5 on both sides, and we're going to end up getting y equals -1. So our final solution is what we call an ordered triple. It's the point 2, -1, 1. And that's it.